Now finally, to demonstrate a mirror vault environment, we're going to create the exact same destination volume again. So I removed it, I'm going to recreate it and set the second part up again. So we start with a 5 GB destination volume, and we make sure that it's on the second cluster in the XDP DST SVM. Then we create a SnapMirror relation again of the type XDP, so it's all the same as before. But here comes the difference. Now we're going to set up a SnapMirror policy, and that policy will not be of the type Vault and will not be of the type async mirror, but it will be of the type mirror vault. So the mirror vault policy will be of the type mirror vault. And obviously mirror vault as a policy name is arbitrary, but the important thing is the type should be mirror vault. So we connect that particular policy to the SnapMirror relationship, and obviously we have to initialize it. So after having initialized it, we will make sure that we can mount the new destination volume from our Linux machine. So the source volume doesn't change. It still has the data, and so we can mount the destination volume to the junction path, and then we should be able to access it. Of course, we also have to connect the read-write policy to that particular volume, otherwise we won't be able to mount it. So that's done. Now let's have a look on the client. Let's first go to the directory that contains the XDP volume, and what we see is we have A, B, C, D, E, F, G because we initialized it, and it is the same as the source again. Now we're going to add another file, or another 3 files I should say, and then we're going to update the relationship based on a snapshot that we create. Now we call the snapshot mirror vault snap, and we're going to run the update based on that particular source snapshot. And we update the relationship. So now the destination should have these 3 new files, and there they are. But the nice thing now is, even though it's an XDP relationship, we can break the SnapMirror relationship because it is a mirror vault. And once we've broken it, we will be able to continue working on the destination. So we break it, and after it's broken, we should be able to write on the destination of an XDP relationship. And we are done. Now, in the previous lessons, we have been talking about all of these SnapMirror possibilities. SnapMirror used to be asynchronous only, so the data would never be in sync for 100%. This meant that you would always lose some data when a disaster recovery would take place. So the recovery point objective would never be 0. In ONTAP 9.5 and later, we offer synchronous SnapMirror. So in pre-9.5, you would only have asynchronous SnapMirror, so no 0 recovery point objective, because the data will be replicated in sync with synchronous SnapMirror. Your latency should be very low, so the maximum distance would be around 150 kilometers. There are 2 different ways in which you can set it up. The first one is a regular SnapMirror sync, and the second one is a strict SnapMirror sync. We'll have a look at the differences in a second. Imagine you have 2 data centers, DC1 and DC2. The source volume is in DC1 and the destination volume is in DC2. The client sends the data to the source volume in DC1. The data will be replicated in parallel, so the write to the source is synchronously written to the destination as well, and when that is a fact, only then will the client receive an acknowledgement. In SnapMirror Sync, when the destination data center or volume is unreachable, the client will still be able to write data to the source. And when the destination comes back, the missing data will be replicated, and the 2 data centers will be in sync again. In SnapMirror Strict Sync, the destination always has to be reachable for a client write to be successful. When setting up a SnapMirror relationship, you can specify the sync policy for SnapMirror Sync when you create the relation. and strict sync if you want it to be a strict relationship. And of course, then you initialize. Hope to see you again in the next module.